Let's talk about the height of the projected object. Now, we've talked a little bit about this last time because you guys who are football players, we talked about it. You're going to have a long pass that goes down the field. Is it going to be a line drive? No, there's a limit to how far you can throw a line drive, right? If you're going to want to get it way down the field, it's going to have to go up in the air, and then it'll come down and make a big arc, right? It's got to have some air time, some hang time for that to get that far. There are other things in the real world. Have you guys ever watched the movie October Sky? No? Oh, you should watch it. It's a really good movie. It's about this kid that worked in the coal mines back in like the late, well, his dad worked in the coal mines back in the early 60s when the space race was starting. And so it was, everybody in the country was all excited about the idea of building rockets and going to the moon. And they were, you know, racing against Russia to see who would be the first man in space. And so this kid he has a science teacher who sort of encourages and helps him learn how to build rockets. And in this one part of the movie, he and his friends, they'd shot off this rocket, and they couldn't find it. They would go out and search for him after they would shoot, and they couldn't find it. Well, somebody not too far away had their barn burned down, and everybody thought their rocket must have set that on fire. And they're going to tell them, you can't do this anymore. You can't build any rockets. In fact, they were probably going to press charges for burning down this guy's barn. So the kid knew enough math to be able to go back and calculate where that rocket should have landed. Now, the problem is there's like a range, because depending on the wind and everything, it may not be that he can say exactly in this spot, but there would be an area where he knew he should search. So by knowing the math, you can figure out where something is going to land or how long it would take for it to get there. And that's one of the things we're going to talk about. You could also figure out if you wanted to throw something off the top of the building, or drop something off the top of the building, how long it would take before it would hit the ground. Has anybody ever gone skydiving? I haven't either. Anybody interested in going skydiving? Really? Okay, I'm too chicken. I don't think I would do that. But I do know enough about it to know you don't want to open your parachute the instant you jump out of the plane. Why would that be? Say again? Well, it would take you longer to get down, but I also think there's sort of this distance from the ground that you got to open it by this point, or you're not going to have enough time for the parachute to slow you down before you smack the earth. But if you open it too soon with the wind and everything, you probably have a harder time hitting your target. So there's a lot of math that goes in to somebody who's telling you, now wait until you count to such and such before you open your chute, or you know, wait till I give you the signal because I've got to count to such and such. So all of these things really are controlled by math. And so here's what I want you to think about. If you launch a rocket from the ground and the initial velocity is just another word for what? Speed. Very good. That's how fast it's traveling when it leaves. It's 73.5 meters per second. We're going to neglect air resistance because that would complicate our formula a little more. The height in meters above the ground after you launch it, and we're going to count in seconds, so we'll use T to represent that, is given by this formula. Now, I want to talk to you just a little bit about what you see here in this formula, okay? I'm not sure why I use the letter S to represent height, but it tells us that this is how you would figure out how high it is after so many seconds. Now, I do recognize seeing 73.5. Where did that come from? That was my velocity. So guess what? If we're talking about something that gets shot in the air, real world math here, whatever is in front, whatever your B value is, whatever is in front of the variable, in the real world, usually what we're doing is comparing something against time. Something's changing over time. So our height is changing over time. And this value is going to be how fast it was moving when it left. Okay? That's kind of cool. There's a reason why that number is there. These aren't random numbers. Now, the other number that I see, I didn't see a negative 4.9 anywhere. And by the way, those of you who know a little bit about parabolas and quadratic equations, why is it negative? What does that mean if I'm looking at the graph of it and it's negative? Which way does that parabola open? Say again. It opens down. So this is telling me, now think about it. If I shoot something up in the air, shouldn't it be this kind of shape that it's traveling? Absolutely. So I know why it's negative. It's because you're shooting it in the air and then it's going to come down. So it's that upside down arc. And why do you think that 4.9 is there? Where did that come from? Think about, say again? Well, think about this for a minute. If I shoot something up in the air, do I know it's going to come back down? Why? Gravity. This is the force of gravity on the earth in meters per second. If we had been talking about feet per second, it would have been a negative 16. These are like magic numbers that are always in these real world problems based on the units you're using. Now, you don't have to memorize this. I just want you to understand these aren't just, you know, random numbers somebody made up. They all represent something. Now, by the way, where did this thing get shot from? What did it say? From the ground. So I don't see a C value in this. Do you? Okay. This would be the same thing as +0 on the end. Because guess what? This is going to tell me what my starting height was. What if I'd shot this off of a building that was 50 feet tall? It would have a +50 at the end because that would be my starting height. Okay? So there's a reason if you take science classes, if you do physics, for example, you work with problems like this all the time. Physics is just applying math in the real world when you start talking about motion and things like that. So here's what we're going to do. Now that we've looked at that equation, we're going to try to answer after how many seconds will the projectile be 100 meters above the ground. Now, I have a typo here, okay? So we're going to fix that in just a minute. But I want you to think about this for a minute. I have how many variables up here? 2. An S, which stands for, what did we say S stands for? The height. And the T, which stands for the time. Okay. So here's what I got to ask myself. If I'm supposed to find after how many seconds this is going to be 100 meters above the ground, what am I looking for? Am I trying to find a height or am I trying to find a time? A time. After how many seconds means I'm looking for T. Okay. So it means they must have given me, this number should be my what? The S, which is the height. So if they give me a number that represents height, where do you think I'm going to plug that in? That's right. We're going to plug in the number they gave us, 100, for S. So I'm going to take this equation and I'm going to put 100 equals negative 4.9 T squared plus 73.5 T. Once I do that, should I know where to go with this thing? Yeah, this is a lot like what we were working on back in chapter 4 or lesson 4. The only thing that probably is a little uncomfortable is what do you see here that you probably don't like? Say it again. Well, the fact that it's got the T squared does tell me that it's going to be quadratic. I'm thinking it's the decimals that I'm a little nervous about just because we really haven't used a lot of decimals. But let's see what happens. What do you think I need to do with this thing before I go any further? Now think for a minute. If I see it's, I got to set it equal to 0, and then I can solve. So to set it equal to 0, I'm going to subtract 100 from each side. And 0 will equal negative 4.9 t squared plus 73.5 t minus 100. Okay, now at this point, I've got a decision to make. We just reviewed our 3 different methods for solving quadratic equations. Do you think this is a good candidate for factoring? Probably not, because of the decimals. Now, the exception to that would be if I knew that, say, 4.9 would divide evenly into 73.5, and it would also divide evenly into 100. I might try factoring, but if I try doing that real quick, I'm going to tell it doesn't divide in evenly. Here's another thing I want you to think about. This is sometimes good to keep in mind. Any of you guys run track? Even as a football player, is that like when you're being scouted, are they interested in how fast your 40 is or your whatever? Yeah. So if you run track or you get timed for how fast you run, at a track meet, do we end up on a, say, a 40-yard dash or 40-meter run having first place finish at 5 seconds, second place finish at 6 seconds, third place finish at 7 seconds? That's not usually the way it works, right? Because it's usually more like what? 5.2 something or 4.8 something. And that's because we can measure time in fractions of a second, right? We can have decimals there. And if that's the case, that doesn't sound like a good option for factoring. That sounds like we probably need to use what? Quadratic formula. So are we ready to identify A, B, and C? Tell me what's A. Negative 4.9. B is 73.5. C is negative 100. You ready to sing? Da 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 da. 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 Okay, sing it with me. What is it? Negative B plus or minus the square root of b squared minus 4ac over 2a. Snap, snap. You guys getting it? Yes? You getting the formula down? You know it? Okay. So here's what we'll do. We will put in those empty parentheses, and we're going to start plugging in, and we're going to see if we can clean this up and come up with an answer that would make sense. Okay, so what number goes in for B according to 73.5? So I'm going to put a 73.5 here and a 73.5 here. What goes in for A? Negative 4.9. And what goes in for C? Negative 100. And we have a negative 4.9 down here. All right, got your calculators? You're going to need them. So I know I have negative 73.5. And on this one, we're actually going to need a decimal number. We're not going to have any simplified radicals here because we need to, I mean, have you ever had a track meet and they announce the winner and they say, with a winning time of the square root of 22 seconds? That would be weird, would it not? So we need to come up with a decimal approximation. This is where you will want to come up with something in the calculator. So I can take 73.5, square it, and then subtract 4 times negative 4.9 times negative 100. And can you guys tell me what belongs under this square root sign? Anybody else get that, or did y'all get something different? If I do 73.5 squared, and then I subtract, and in parentheses, I do 4 times negative 4 times negative 100. I am getting 3,802.25. Anybody else getting that? You need to be sure you know how to get this in the calculator correctly. okay, over 2 times negative 4.9 is a negative 9.8. Now here's where it's a little bit different from what we've been doing. We're going to have to do a negative 73.5 plus the square root of this number, and then take that number divided by a negative 9.8, and that's going to be an answer. But we also have to come back and do negative 73.5 minus the square root of this number. All right, you got your calculators. You need to practice this to make sure that you're getting this in your calculator correctly. So if I have negative 73.5, and I want to add the square root of 380, and now I can't tell, was that supposed to be a 7 or a 2? Can you help me out, Patrick? Was that 7 or 2? 380. Did you have it? Oh, you didn't have, I thought you had that number. Okay, hold on.
I even did.
I think it's 3802.25. Okay, let's try that. Okay, so if I have negative 73.5 plus the square root of 3802.25, I'm getting a negative 11.8376 over negative 9.8. So if I divide that by negative 9.8, then I'm getting 1.2 seconds. Does that make sense? Are y'all getting that? And then if I take negative 73.5 and I subtract that square root from it and divide it by negative 9.8, I'm getting 13.8 seconds. Now I have a question. Does that make sense? How am I getting 2 answers? Yeah.
I don't know why I'm getting the wrong answer.
Okay, hold on a second. And okay, so we just double checked and I had a mistake here. We're going to fix that. This is not supposed to be 3802.25. This is supposed to be the square root of 3442.25. So sorry. I think I must have hit the wrong button in my calculator. And that's going to change our computation, right? Because now if I do a negative 73.5 and I add the square root of 3442.25, I'm going to get not negative 11.8376, but I'm going to get negative 14.829. And if that gets divided by a negative 9.8, I'm getting 1.5 seconds. Okay. So our concept is right. The original, what I put in at first was not the right number, so these were off a little bit. Now let's go back and try it again with negative 73.5 minus the square root of 3442.25, and that's a negative 132.1706. We're going to divide that by a negative 9.8. And that rounds to be 13.5 seconds. Okay, sorry about that. I'm glad you asked, Patrick, so we got the numbers fixed. So 1.5 seconds, 13.5 seconds. You got to be sure you know how to get it in your calculator correctly, because obviously it's very easy to make a little mistake there. Now, first of all, are these answers reasonable? Because remember, it's asking us after how many seconds will this thing be 100 meters above the ground? Would it have made sense if we had gotten a negative number, like negative 0.3 seconds? Why not? Because if I get, can you get a negative time? Can we go back in time? If you figure out how to do that, you will make all the money you could ever possibly spend, because there are a lot of people who like to time travel. But no, negative time does not make sense. What if we'd gotten something like 2,715? Have you ever seen something that if it doesn't go through the Earth's atmosphere, it's going to hang in the air that long? That's a long time, right? I mean, 15 seconds is pretty long for something to hang in the air. Have you ever had a quarterback that could have a pass hanging for 15 seconds? No, you got to have something with more force to be able to be longer than just a few seconds. But if it was very long, it wouldn't make much sense either. So I would say this is logical, but why are there two? Why are there two answers? Why does it say 1.5 and it says 13.5? Does that make sense? So think about what this is doing in the real world. So you shoot this thing off from the ground, and it's going to go up in the air. Eventually, it's going to hit a point and it's going to come back down, right? If this is 100 meters, does it make sense that it's going to hit 100 meters on the way up and it'll hit 100 meters back again on the way down? That's why there's two answers. In between 1.5 seconds and 13.5 seconds, this thing is more than 100 meters in the air. Make sense? So one is the time going up, the other is the time when it hits 100 meters coming back down. All right, give me a quick signal in terms of, does this concept make sense? Either here, here, or here. Not can I come up with the right answer all by myself, but does the concept make sense as far as I kind of understand what I'm supposed to be looking for and why I get two answers here, what this would look like in the real world. Okay, in terms of the actual calculations, here's the good thing. You're going to be given an equation. I'm not going to make you write an equation on this. As long as they give you the equation and you've got one value, you've got to figure out where it plugs in. Even though the numbers might be a little messy, do you think you can figure out the how to finish it off? We're going to practice and find out. Now, there's a follow-up question to this. And it says, how long will it take for the projectile to return to the ground? So we already know if you shoot something in the air, eventually it's going to come back down on the ground, right? So the idea here is we're going to shoot this thing in the air. We want to know when does it land back on the ground. Now, when I shoot it off, what's my time here? Yeah. At time 0, it's on the ground. Then I go bang, shoot it off, and I want to know when is it going to land back on the ground. Now remember, the equation they gave us was S equals -4.9 t squared minus 73.5, or was it plus? Now I need to double check on that. It's plus, okay, thanks. Okay, so it's plus 73.5 t. So on the last one, they gave us a number. We had to figure out where we plugged it in. This one, they didn't give us a number. So think with me. What would be the height when it returns to the ground?
0.
0. What do you think we should maybe do in this equation? And 0 is going to go in for which letter, the S or the T? There you go. Because we want to know when the height is 0, what time will it be? So you just have to stop and think, what's it asking for and what have they told me? So I can figure out what to plug in. When the thing's back on the ground, the height above the ground is 0. Now, you have any idea what can we do to solve this one? It says 0 equals -4.9 t squared plus 73.5 t. What might be a good plan?
I don't know if the 0 back.
We can always use quadratic formula. And if you want to use quadratic formula, you can. This is sort of like the one we did at the end of class last time, where we had the Pythagorean theorem question. And remember, our C became 0. Our C is 0 here. Do you see a common factor? I could factor out T. And if I factor out T, what would I have inside the parentheses? Negative 4.9 T plus 73.5. Now, do I have two factors there? Do I have two factors? I don't have two parentheses, but do I have two factors? Yes, because my common factor is T. So that's one factor times this parentheses. Would it make sense to say either T equals 0 or what else can happen? T can equal what? The only way I multiply two things together and the answer is 0 is if one of the values is 0. So either T equals 0 or T is going to equal whatever I get when negative 4.9 T plus, not T, yeah, plus 73.5 equals 0. That parentheses when it equals 0, right? Either T equals 0 or the parentheses equals 0. Now, what can I do to solve for T here? Exactly. My 4.9 T is negative, so let's add 4.9 T to both sides. I could move either one of the terms, but if I do it this way, I don't have to worry about negatives. And I said 73.5 equal to 4.9 T. To finish solving for T, we're going to need to do what? Divide by 4.9. Go to your calculator. What is T equal? I think it ends up being a nice number. What is it? It came out to be an even 15. Now, stop and think for a minute. What was the question they asked us to find? What would be the time that this thing returns to the ground? Would T equals 0 make sense? Because why? I haven't shot it off yet when T equals 0. It's still on the ground because I haven't shot it into the air. So that's before I shoot it. T equals 15 seconds is when it returns to the ground. Okay, so there's a lot of analysis you do here, which means you got to think your way through, what do I know? What am I looking for? What does that mean? And those are going to be the two kinds of word problems you should see in section 1.5. Okay, questions? All right, so let me do this. Stop recording.